All right, so for 9.6, we are going to go through solving logarithmic and exponential equations. So we've seen a little bit about how we use logs and exponents to undo equations. So we're going to use a little bit of that here. First, we're going to start with this, solving exponential equations. If we have equations such as 3x equals 20, 2 times 5x equals 64, these are exponential equations because x is in the exponent spot. If we want to solve these, we're going to use what we call the base exponent property. So the base exponent property says if we have two numbers equal each other the same base, their powers are going to end up being equal to each other. So we'll see here in a second how we can use this. So we have 3x minus 7 equals 32. And we'll be able to solve this. So what we know is that if I have the same base on both sides, then I can make those powers equal to each other. So I just have to rewrite this so that 32 is a base 2 exponent. That's pretty easy because 2 to the 5th is 32. So this means that I can just say, well, 3 to the x minus 7 is equal to 5. Like I said, that's just using that property here. So like I said, we just have the same base, so we just set the exponents equal. Then we just have to solve for x. So we add 7 to both sides. We have 3x is equal to 12. That means x is going to be equal to 4. And don't forget, it's beneficial to check some of this. So if x is actually 4, we would have 2 to the 3 times 4 minus 7. And we want to see if it equals 32. Well, that's 12 minus 7, which is 2 to the 5th, which is going to be, yes, we get 32 equals 32, so it checks out. This is the correct answer. All right, and that's just going through it too and checking. So for 13, both of these, we have to rewrite them. So we have the same base. So we see we have 3 here, so that means we have to change 81, so as a base 3 exponent. Here we got 25, and we got 1/5. So we might have to convert one or both of them so we have the same base exponent. But take a minute and work on those, and then we will do them. All right, so for A, like I said, we have the 3 here, so we get 2 to the x minus 6. So we can look at what power of 3 may give us 81. If you played around with that, you may have found that 3 to the 4th is 81. So now we have the same base. That means that 2x minus 6 is going to equal 4. If I add 6 to both sides, I have 2x equals 10. If I divide by 2, then we get that here, x equals 5. And you can just double check here. If we had 2 times 5, 10 minus 6, we'd have 4, 3 to the 4th. That is the correct answer. So B was a little more extra work. So we got 25 here and we got 1/5. So what we can do with 25 is just 5 squared. So we can say, well, that's just 5 squared to the power of 4 minus t. 1 to the 5th, because you got 1 to the 5th, you can change that. So we have a positive power, that is 5 to the negative 1. So we can change the other side to 5 to the negative 1, and that's all raised to the power of 3t plus 1. So as a reminder again about rules of exponents, move a few things out of my way. If I have a number raised to a power and then I raise it to a power again, I just multiply those powers together. So this is just actually 5, 2 times 4 minus t. The other side is 5 minus 1. times 3t plus 1. So we really have 5 to the 8 minus 2t and 5 to the negative 3t minus 1. Regardless we got or anything else going on here, we have the same base. So this is just 8 minus 2t, and this is negative 3t minus 1. So I'm just setting the exponents equal to each other. So now we just solve for t. So I'm going to add 3t to both sides. We have 8 plus t equals, where was I? Negative 1. If I subtract 8 from both sides, we get t is equal to negative 9.